Okay, chapter 8 notes. Very easy, chapter 8. I like it. Um, we're gonna start with delta H, okay? Delta H, when you're working with a reaction like this, delta H should be equal to products minus reactants. But when you're working with bonds, uh, it should be somewhere here. Somewhere. Is it not here? Oh, bonds, yeah, I'm home. Okay, but when you're working with bonds, it's the bonds of the reactant minus the bonds of the product. Okay, yeah, like here. So you'd add, if you're working with bonds, you'd add these up, then subtract this. Okay, let's start. Over here, you have given heat of A is 60, B is 10, C is 0, D is 100. Find delta H. Okay, when you're working like this, we do products minus reactants, but when it's bonds, we do the opposite. So the products here, C is 0, D is 100, so 300, because it's 3 times 100. A is 60, B is 10, so 2 times 10, 20. So let's subtract them. 300 minus 20 minus 60, you get 220 kilojoules. That's positive, okay? Uh, here, 2A, so A is 60, so 2 times 60, 120. B is 250, so 250. Okay, and then the products you have C is 100, so 2 times 100 is 200. 3 times D is 50, so 3 times 50 is 150. So you add these up, you get 350, and then you subtract these, you get 100 minus 1, negative 20 kilojoules. Okay, using table 2, what's table 2? What is table 2? Okay, I mean, I think in table 2 they just give you what the heat content of everything here is. So if you do have the heat content, again, just add them up and then subtract. And in the case of you having a coefficient, then you multiply the heat content by the coefficient, okay? Which of the following is endothermic? Obviously, the endothermic ones would be the positive delta H. This is negative, so لا. This is positive, أكيد yes. Heidi, you have energy being absorbed because it's on the left, it's in the reactants. If it's being absorbed, أكيد it's endo. Hon, you have the energy in the product, so it's being released, it's going to be exo. Okay, here you have a positive delta H, so it's correct. Uh, you have, okay, yeah, these examples, it would be nice to know them, of the exothermic reactions, because they always come. I always see combustion, where's combustion? I always see combustion, that always comes. Condensation, freezing, always know SLG, solid, liquid, gas. If you're going to the right, it's endothermic, okay? Uh, let's go question 4. From your own knowledge, which reactions are endothermic? Is this endothermic? No, okay, it's exo. Uh, this, I think you have to memorize this. Okay, dissolving NaOH in water, it's sodium hydroxide. It releases hydrogen gas, right? It really, I think, does it? No, wait, it releases ions. Okay, insa. But from what I know, this is exo because it makes the beaker hot. I remember that. NaOH, dissolving it in water, it's hot, it's here. It's exothermic. You memorize it. NH4Cl, is that also here? Uh, neutralization reactions with acid and a base. Okay, that's exo. NH4Cl. It's gonna be endothermic. Because I looked at it over here. Dissolving ammonium chloride in water is endothermic. Ammonium chloride is NH4Cl. Okay. Uh, NH4Cl, ammonium chloride in water is endothermic. A nice way to remember it, ammonia. Okay, ammonia is always cold. Okay, melting ice, SLG. So you're going from solid to liquid. So akid that's going to be endothermic. So these two are endothermic. This is exo. Reacting NaOH with hydrochloric acid. This is also exo. Okay, you're reacting a base with an acid. Those are always exo. Heating carbon with water to form water gas. Okay, anytime you're heating something, that means that solution is absorbing energy from the heating. So that means it's endo. That's one way to know it. Or you could just memorize heating carbon with water to form water gas. Okay. potential energy. Okay, instance. So, for an exothermic reaction, okay, choose which is correct. Is delta H negative? Akid yes. Products have more heat content? Akid no. Reaction releases energy? Yes. Reactants have more heat than products? Yes. Delta H is positive? لا. Okay, reaction absorbs energy? أكيد لا. Question 6. For an endothermic reaction, is delta H negative? لا. Products have more than the reactants? Yes. Reaction releases? أكيد لا. Reactants have more than the products? Reactants more than the products? لا. Delta H is positive? Yes. Absorbs? أكيد yes. Okay. I only go over the questions, but it would really help if you guys went over the notes. يعني read them. They're very يعني important. This isn't a question, but you calculate the bond energy, calculate the sum of the bonds broken, calculate the bonds formed, and subtract. Uh, so you can use them here. Over here you'd have, let's calculate the bonds. You have a double bond for carbon, so 6O2, okay, and then you have 4 CH bonds over here, so plus 4 times CH, which is 413, plus ClCl, which is 240. Okay, let's put this in a calculator. 602 plus 4 times 413 plus 240. 2494. Okay, and then for the products, you have, let's move this here. You have 1, 2, 3, 4 CH bonds, so 4 times 413 again. You have a CC bond, single, okay, 346. Okay, and then you have CCl, 2 of them. Okay, 2 times 327. Okay, so let's put this in a calculator. 4 times 413 plus 346 plus 2 times 327. You get 2652. And then we always, for bonds, we subtract the reactants minus the products. So 2494 minus 2652. You get negative 158. Is that correct? What question is this? 6 negative 158. Okay, yeah. And if you do uh calculate the enthalpy change, yeah, make sure to put in the unit. I mean, maybe it comes written. I hope it doesn't. I mean, حتى if it does, it's very easy. Given the following values for the bonds, calculate the total. Okay, same thing. Okay, NN, the triple bond is 945. Okay, then you have 3H, HH bonds. So 3 times 436 plus 3 times 436. Okay, هون عندك 3 NH bonds. So 3 of these. So 3 times 389 plus again 3 times 389. Okay, and then put them in a carry. I'm not gonna put it, just whatever you. So you get bonds broken. Yeah. Okay. 3 times. Okay. Then 6 times 3. Yeah, 3 3. Okay. Yeah. Subtract this reactants minus products. You get negative 81. Is it exothermic or endothermic? أكيد since delta H is negative يعني it's gonna be exothermic. Okay. Question 7 calculate and okay, I'm gonna skip this. Okay, we did it up here. Similar to it يعني. Okay. Again, this one here, I'll skip it. Okay, this comes always. Calorimetry is the measurement of the heat of reactions. Okay, the device is called the calorimeter. Okay, whatever. Okay, using a calorimeter, Q equals MC delta T. Okay, I think we're gonna get this in our written, to be honest. Okay, Q is your heat energy. Okay, M is the mass of the solution. C is the specific heat capacity or the heat content. Okay, how you can know what C is? Okay, C always is يعني C is always it's always in this unit, or sometimes they say the energy needed to raise the temperature of water by raise the temperature of 1 gram of water by 1 degree Celsius. Anytime you see that, that's how you know what your C is. Okay, keep the mass is pretty obvious. Okay, delta T is the change in temperature. That's obvious as well. Okay, I'm gonna solve the questions here, and I'm gonna solve the questions in the course revision because I think صراحة it's gonna come in the no in the written. Okay, and it takes 0.71 joules to raise the temperature of 1 gram of graphite by 1 degree Celsius. فأكيد this is my C. Calculate the energy to raise the temperature of 1 mole of graphite by 2 degrees Celsius. Okay, graphite is carbon. Okay, graphite is carbon, by the way, and you know carbon equals 12. Can we do MC delta T? Yes, we can. Okay, the mass, since it's 1 mole, its mass will be 12 grams, right? Because N equals M over M. If it's mole is 1, mass, we know the molar mass is 12. Cross multiply, you get 12 grams. Mass is 12. Its C, we said, is, this is carbon. The C is 0.71 joules. 0.71. And the temperature is 2. And you get whatever it is. Question 8, so 12 times 0.71 times 2. Yeah, 17 joules. Is it 7? Did I see 17? 17. So Q equals 17. Okay, this is joules. Okay, this is when they ask you to find the energy. Okay, but sometimes they say calculate the enthalpy change, or they say calculate the heat content or molar heat of vaporization or something like this. Okay, or the heat of combustion. Okay, so let's continue here. Raise the temperature of 24 grams. They gave you the mass 24 times the C 0.71 times the temperature 5. You get, let me see, 24, 0.71, yeah, you get 85.2. They rounded to 3 significant figures. Please pay attention to the significant figures in the written. Here, Akid, you just subtract them, you get 2. It doesn't matter if it's in Kelvin, by the way, for this formula. Only for this formula, it doesn't matter. Raise the temperature of 36 grams of graphite for Akid 36 times 0.71 times 2. Okay. Yes. Okay. Now, when they say calculate enthalpy change, we say delta H is minus Q over N. Okay? So, question 5. When they say enthalpy change or heat of combustion or heat of molar heat of vaporization or something like this, okay, you always use minus Q over N. But sometimes Q won't be given. Okay, here in this case it's given. But in the written part, in the makeup, it wasn't given. They had to find it. I'll show you both cases. To change the temperature of a particular calorimeter and the water it contains by 1 degree requires 5 kilojoules. Okay, so they actually gave you the energy. Okay, uh, so this is actually our Q, right? Because they gave you it in kilojoules, in joules, whatever. That means it's our Q. Up here was it kilojoules or joules? Okay, so we know the Q. They said heat of combustion, huh? They could set complete 0.7 grams because the temperature of 5.3 degrees, whatever. Find the heat of combustion, okay, in kilojoules per mole. By the way, if you don't know the formula, kilojoules is Q, moles is N. So Q over N minus Q over N. It's always negative. Don't forget the negative sign, please, huh? Okay, فنحن we want delta H, and we know it equals minus Q over N. Okay, we have our Q, which is 5, so negative 5, over the moles. Do we know how to find the moles? 0.7 grams over 28, right? So 0.7 over 28, that's our moles. So 0.7 divided by 28. Okay, and I don't know what you get. You should get minus 500, I think. What question is this? 5. Minus, this isn't the same. 135. It's not the same. Is it the same? Ah, they said 5.3 degrees Celsius. Oh, shit. My fault. I didn't see it. Hold up. Sorry. They gave us the Q, okay, for 1 degree Celsius. Okay, for 1 degree Celsius, they gave us the Q is 5 kilojoules. Okay, and I didn't see the 5.3 degrees Celsius. Okay, they said blah 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 blah. 0.7 grams will cause 5.3 degrees Celsius. Find the heat of combustion for this 5.3 degrees Celsius. Okay, we said it's minus Q over N. And the energy will change depending on how much the temperature rises, right? So we said for 1 degree Celsius it's 5 kilojoules. So can I find out how much is this for 5.3 degrees? Yes, I can. Okay, all I do is just cross multiply x kilojoules. Okay, you cross multiply and you get how much? How much is it? 26.5. Okay, so you're gonna get our Q is 26.5. Okay, now you just, it's a direct application, 26.5, a negative 26.5, because it's minus Q over N, over the moles, which is N equals M over M, the mass divided by the molar mass, so 0.7 divided by 28. Okay, you get negative 1060. Okay. Before moving on, and I want to solve the rest of, I want to solve any question that looks like it, because uh, they came, and what do you call it, written. Okay, if I look through the course revision document, there's no question that there's no more questions actually uh, have to do with this topic, but I'll find the written that came, because maybe they get something to do with it. Okay, I'll cut. Okay, this was in the makeup. Okay, uh, a question was like this in the quiz, I think. Um, 1,376 grams of hexane are burned in a calorimeter containing 500 grams of water. What's the molar heat of combustion of hexane if the water temperature rises by 20 degrees Celsius? They said the heat capacity of water is this. What is the molar heat of combustion? When you see molar heat of combustion, or heat of vaporization, or heat of whatever, or heat whatever, okay, that means they're asking for delta H, okay, and delta H is minus Q over N, but they didn't give us the Q. Okay, they gave us the C. They gave us, well, two masses. Okay, so we can just say they gave us a mass, and they gave us a temperature. So do you think I can find Q? We know Q equals MC delta T. Okay, so we can find Q. Q equals the mass. You're gonna ask, Tab, look, this is what our friend here did. He added up the masses. I mean, well, that would be the logical thing to do, right? But no. What solution are we talking about? What heat capacity do we have? Water. So what do we take? We take the mass of water. So 500 times 4.184 is the C, times the temperature, 20 degrees Celsius. Okay, and you get whatever you get. Yeah, you get something. Okay, and then you get that Q. Okay, uh, you get that Q. Wait, hold up. But how did he calculate the moles? Oh yeah, so he for his mole. Okay, sorry. Delta H minus Q over N, right? We got our Q. Now for the moles, they gave us the mass, right? And everybody should know how to find the molar mass of water. It's H2O, which is 18. Two hydrogens plus one oxygen. Okay, so can we find the moles? Yes, it's M over M. So it's gonna be the mass of water, which is 500, over the mole. Wait. Okay, well, yeah. After I took a look at it now, okay, when you're doing minus Q over N, you're gonna find the moles of hexane. Okay, so we found the Q for water because the temperature of the water was rising, but we're finding the molar heat of combustion of hexane. Okay, so that means for delta H, for the molar heat of combustion يعني delta H, delta H for hexane. بس ال Q نحن we did it for water لأنه it's the temperature of the water that's rising. Okay, ف whatever answer you got here, we're gonna find now the moles of hexane, which is 1376. Okay, and see, they wouldn't give it to you if you weren't going to use it. C6H14. They wouldn't just give it to you if you weren't going to use it. The molar mass of 16 of C6H4 would be 12 because each carbon is 12. So 12 times 6 plus 14 times 1. Okay, you do this on a calculator. Divide this answer by this answer. And whatever you get, make it two significant figures. Because you take the least number of significant figures. In this case, it's 20 degrees, which is two significant figures. Okay, okay, so let's continue with the notes. Question 8, what is the delta H for this reaction? Obviously, it's being absorbed, so it's going to be positive 68 kilojoules. Okay, rewrite the reaction per mole of NO2. This is what came in our written in the periodic. Per mole of NO2, that means we have to divide everything by 2. So it will be half N2 plus 2 divided by 2 is just 1, so O2. Okay, put in the state symbols, plus divide this by 2, you get 34 kilojoules to produce NO2. Okay, rewrite the equation per mole of O2. This is the same answer. What is the delta H for the following reaction? So here they just reversed the reaction, so they flipped it. Okay, so obviously it's since we flipped it, we didn't divide or anything, it's still the same coefficients. It becomes negative 68 kilojoules. Okay, question 9. Which of the following equations is equivalent to N2 plus 2O2? Okay, okay. So the delta H in this case is plus 68. Okay, so we're gonna want to look at the ones that have plus 68. So this, obviously not this, obviously not this, obviously not this, obviously not this, and this one will be correct also. Okay, because per mole N2. Oh, wait. No, 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 no. Sure. Wait. This one is correct. Okay, this one. Did they flip it? It would only become negative if they flip it. They didn't flip it, so it's wrong. Here it would become 34 if they divide by 2. Did they? Yes, they did, so it would be correct. Okay, 68. Yes, this is correct. Negative, that means they flipped it and divided by 2, but they only divided, so it's wrong. They didn't flip, so it has to say positive. Here, they should have divided by 2, but they didn't, so it's wrong. It's only these three that are correct. Okay, question 10, write the reverse. Very easy, just flip it, flip everything. It's going to come C2H6 to produce 3H2 plus 2C, and the delta H would just become positive. Okay, question 11. Given this, we write it per mole of Fe, so you have to divide everything by 4, and this would become 3 over 4, just become 1 over 2, because 2 over 4 is the same as 1 over 2. Okay, so on and so forth. Okay, just divide everything by 4. And then if it was per mole of C, then you divide everything by 3. Okay, put it all over 3. And had to this one here, you divide it by 3. Here. Rewrite the equation, this reaction, rewrite it as smallest whole numbers and express the heat of the reaction. So it's 1 over 2. Since we want to make it smallest whole numbers, we have to multiply the whole equation by 2. This, if you multiply by 2, it cancels the fraction. Here as well, it's going to cancel the fraction. Here you multiply by 2 becomes 2. Okay, and since we're multiplying everything by 2, we have to multiply the energy, so it becomes minus 72 kilojoules per blah 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 blah. Okay, per mole of H2. Oh, okay, so you can say negative 72 kilojoules per mole H2. Okay, they said per mole H2. So you just the same thing. We just write the delta H. Say delta H equals this. How much energy is liberated when 2 moles of HBr are produced according to the above equation? Okay, so that means we want it to be 2 moles of HBr. In this case, we actually do. Uh, why did I stutter? I know I'm stuttering a lot. Yeah, uh, 2 moles of HBr here, 2 moles of HBr. We have it already, so there's no need to do anything. So you can just say minus 72 kilojoules. Okay, question 2, consider this. Calculate the heat change when. So over here, you're gonna have to do RR and GR. Let's put RR, GR. Okay, uh, we have given 1.6 grams of methane in our reaction for our RR. What's in our reaction? People to this day still don't know how to do RR and GR. In our reaction, we have 1 mole of CH4, and CH4, by the way, is 16 because carbon is 12, hydrogen is 1. So CH4 is 16. So 1 mole of CH4 would be 16 grams. What do we have given? 1.6 grams. What's the energy we have here? We have minus 819. Okay. How much would we have? It would be X. Cross multiply and you should get negative 81.9. I don't know whether you keep it positive. I think, let me see. It would be 81.9, yeah. Because they said heat change. Okay. Heat change and you just keep it positive. Okay. Uh, yeah. Hella Hess's law. These are the ones we don't like. Find the heat of combustion of ethane. So combustion of ethane to form water vapor and carbon dioxide. Okay, ethane is over here, C2H6. Okay, so C2H6. Uh, combustion, that means burns with oxygen, right? You should know that combustion, everybody knows, combustion is burning with oxygen. To produce water vapor, H2O plus carbon dioxide, CO2. Okay, we want to somehow get to this reaction here. Is this balanced? Is it for 2? It's not balanced. So this balance it first. You're gonna want 3 here. You're gonna get 3 oxygen. CO2 here will be okay. It will be multiply the CO2 by 2 because you need to make it 2 carbons. Now you have 4 oxygens, 3 oxygens, so you have 7 on the right side. Let's just multiply by 7 over 2 to make things easier. 7 over 2. Okay, so our final equation should be like this. Okay, how do we make it like this? So what's the first thing we need? We need C2H6 in our reactant side. Here we have it in our product side, so let's flip it. Okay, let's flip it. So we're going to put C2H6. You know what? Let me take this to open board. Okay, so let's flip this one here first because we want C2H6 on our reactant side. So C2H6 to produce 3H2 plus 2C. Am I recording? No? Yes, okay. And since we flipped it, it becomes positive. Delta H1 equals 84.5. Okay, next we need CO2 to be in our product side. And it's in our product side over here. But we want 2 CO2, so let's multiply this one by 2. So it's going to become 2C, because multiply by 2, plus 2O2 to produce 2 CO2. And delta H2 is negative. You multiply it by 2, so it's going to be uh, 78, 786, I think, minus 786. Okay, now we want uh, water in our product side. Here it's in our product side, but we want 3 of it, so we multiply this one by 3. Okay, so H2 becomes 3H2 plus 3 over 2 O2 to produce 3H2O. And since we multiplied it by 3, it's going to be delta H3 is going to be equal to, multiplied by 3, it's going to become minus 726 kilojoules. Okay, so now let's start canceling. Okay, we have 3H2 with 3H2. We have 2C with 2C. Uh, we we can't cancel anything else. We're going to be left with C2H6. 2 plus 3 over 2 is actually 7 over 2 O2 to produce 2 CO2 plus 3H2O. 3H2O plus 2 CO2. CO2. Is this the same as our initial reaction? Yes, it is. So how do we find the delta H? We just add these up, right? So our delta H will be, open the answers. Yeah, okay. You're gonna get minus 1428. Are these the same numbers I got? Minus 726, minus 786, 84.5. Yes. Okay. You get minus 1428. To 3 significant figures? Yeah. To 4 significant figures. Please pay attention to significant figures. Okay, then part B, the thermite reaction. Okay, it involves the reaction between Fe2O3 and metallic aluminum. The reaction produces white hot. Okay, given this, determine the heat liberated in the reaction of 1 mole of Fe2O3 and Al. So they told us the reaction of Fe2O3 and Al produces iron. Okay, white hot molten iron. So Fe2O3 plus Al, okay, produces iron, Fe. Okay, and I think it should just produce Al2O3. Al2O3. I mean, a question like this would be a bit hard to figure out, but they gave us Al2O3 over here. Okay, so we want this as, is this balanced? Should be 2Fe, 2Al. Yeah, I think this is balanced. Yeah, yeah, if this is the reaction we want over here, uh, the way they solved it in the solution is a bit confusing. I think this way is a bit easier, to be honest. But anyway, yeah, something like this wouldn't come, in my opinion. But let's try and figure this out. So we want Fe2O3 on our reactant side. So let's put it in the reaction. So we have to flip it. And we want to divide by 2 because it's 1 Fe2O3. So we're going to start by dividing by 2. Fe2O3 to produce 4 over 2 is 2. So 2 Fe plus 3 over 2 O2. And the delta H here would be, we flipped and divide by 2. So it's going to be 837, 837 kilojoules. Okay. Uh, yeah. Then we want Al2O3 in our product side. So if we have it in our product side, we want 1. So we divide this by 2. So it's going to become 2Al plus 3 over 2 O2 to produce 2 no, to produce Al2O3. and we divide by 2, so this is going to become 1500, 1600, 1674, I think. Delta H is negative 1674. Okay, we'll make sure with the numbers later. But now let's cancel. We can cancel this O2 with this O2, and then we can't cancel anymore. We're going to be left with Fe2O3 plus 2Al to produce 2Fe plus Al2O3. Is it the same reaction? Yes, it is. So can we just add up the delta H's? Yes, we can. Okay, let me check the solution. Is this correct? You get this. Uh, what do they do? Reaction 2 must be reversed. Okay. Okay. I think you just divide by 2. Yeah, well, they got the same answer. If you subtract this, you get minus 837. Okay. Now, question 4. I'll calculate the delta H. يا أخي there's a lot. خلاص, I'm gonna start skipping it. خلاص. No, we did a lot of these like in the quizzes. I'm gonna skip these all Hess's law. And you just have to flip, flip and check. I'll do one more. I'll do. Let's do this one. Part D. Okay. Uh, we want this. Okay, let's take a look. So we want NH3 in our reactants. Okay. Wait. This one is actually so easy. We want NH3 in our reactants, and it is here, and they both have the same coefficient. So we can just write it down as it is. There's nothing to change here. Then we want N2 in our products. Let's take a look at N2 in our products. It's over here in our products, and it's the same coefficient. So we can just write it down as it is. And now let's start canceling. Since we have them both written down, we didn't have to change anything. 2NO2 can cancel with 2NO2. 4H2, 7H2, it becomes 3H2. 7 minus 4, huh? 4H2O, 4H2O cancels. Okay, 2NH3 can't cancel anything, so we just take it down. And then N2 can't cancel anything, so we just take it down. So yeah, it's just easy. You just have to add these up. 400 minus 100. Well, these are very easy, guys. Okay, for this one, the way it's worded here is very like ugly. Okay, so I'm gonna show you how they asked it in the course. Uh, over here. Okay. So see, they said forming water vapor from its elements, like over here. It formed water vapor and released 242. See, and then forming carbon dioxide. Where is it? Carbon dioxide 393 is released. Okay, so same thing. I'm just gonna solve it from here. Okay, find the heat of combustion of ethane to form water vapor. I think we did this. Hold up. Yeah, we did this over here. Question 3. Yeah, yeah. خلاص, I'll skip that. Okay. Uh, Note. Okay, heat of formation under. Okay. Proper. Okay, these are the subatomic particle, the gamma. Okay, I'm not gonna bother doing this. We'll skip to the questions. Okay. Uh, Name. True name. Yeah, I think you just have to say oxygen over here. Name is oxygen. Okay, its charge is obviously 0 because it's not charged. Its mass is 18. Its proton is 8, and the neutrons 18 minus 8. Then here, this is called deuterium, right? We don't say hydrogen, we call it deuterium. Okay, its charge is obviously 0. Its mass is 2. Its protons is 1, and its neutrons is also 1 because 2 minus 1. Here, this is barium. Its charge is 0. Its mass is 141. Its protons 56. Then for neutrons, you subtract them, you get uh, 85. Let me check if this is correct though. Okay, well, now that I look at it, the charge should be plus 8, plus 1, and plus 56. Because over here for carbon and helium, they put the charge as the number of protons. I guess yeah, that works. Uh, Fission, okay, what's this? Fission of uranium gives, okay, what is the charge of the missing. Okay, you're not supposed to see this. What is the charge of the missing element? Okay, you guys know mass is conserved, so you have 92 over here. You have 59 and 0 over here. So 59, 92 minus 59 is gonna be 33. Okay, so obviously the charge would be 33. Then what's the mass? You have 236 over here. 147 plus 3 is 150. So if you subtract them, you're gonna get 50, 86. 86? Yeah, 86. Identify the element. You just go to the periodic table, you look for 8659, and you get as arsenic, whatever. Uh, question 15. Uh, what do they want here? To complete it? I think complete 92. Okay, yeah, I think we're missing something. 90 plus 2 and 94. You have 94, so the charge will be 0. You have 238 plus 4 is 242. Here you have 241. So we're missing 1. So which one has a mass of 1 but a charge of 0? That's a neutron. Over here, you've got 94, you've got 95. So I need to add something to 95 to get me 94. Sorry. So, or you could just do 94 minus 95, you get minus 1. And then the mass is conserved, so 0. What has a mass of 0 but has a charge of minus 1? We know it's an electron. Okay, question 16. Complete the following equation and name the missing particles. Okay, here the mass is conserved, so 0. Here we're missing 1. Okay, which one has a charge of 1? That is, what do you call it? A proton or positron? They said positron? I think positron, yeah. Okay, positron. Uh, Here, 9 minus 9 is 0. 3 minus 4 is minus 1. Obviously, it's going to be an electron. Just write electron. Here 92 minus 90 is 2. Sorry, is 2. 238 minus 234 is 4. So akid is going to be alpha. Yeah, alpha. Or you could say helium nucleus. 235 plus 1 is 236. Let me erase. 235 plus 1 is 236. 137 plus 97 is going to be 234. So you're going to be missing 2 over here. And then 92 over here, you have 52, 92 as well. So you have 0. Okay, whenever you see charge 0, يعني أكيد and it has a mass, يعني أكيد you're working with neutrons. Okay, but does a neutron have 2? No. Okay, so you're going to want 2 neutrons. So 2 and 0, 1. So it's going to be neutron. Okay, I think I'm correct here. Yeah, there's nothing wrong. 234. Yeah, this should be correct. Here you have 1 minus 2, so minus 1 over here. You have 3 minus 4 minus 1, so you have wait, am I tweaking? Okay, um, I'm looking at it. I don't know if I'm missing something. Here you have 5. Here you have 3. So I need to somehow decrease this 5 to 3. So I have to add negative man. That doesn't make sense. Wait. Okay, so I'm not having any luck. Uh, maybe someone in the comments, any, if you know what I'm doing wrong, please tell me because it's really annoying. Uh, I actually can't think of what I'm supposed to put here. Put in the comments, please, if you know. Moving on, complete the following uh, reaction so it becomes balanced. You have 236 over here. You have 233 over here. Okay, so what do we have to add? We have to add 3 and the mass. And here the charges are conserved, so we don't have to add anything in the charge. Which one gives me a charge of 0 but mass of 3? It's going to be 3 neutrons, right? Because each neutron is 1. So you write it like this. Which of the following is a nuclear fission reaction? Fission is splitting of two, sorry, the splitting of a heavy nucleus into two nuclei upon bombardment with a neutron. Okay, so it needs to be bombarded with a neutron. This is forming one heavy nucleus. So this is forming one. So that's fusion. Here, so that's wrong. First one's wrong. Here it's gonna be splitting into two lighter ones. Is it? Yeah, this one here is because it's this one heavy one splitting into two smaller ones. According to physics, it's wrong because it needs to be bombarded with a neutron. Uh, So there are two different definitions we took that contradict each other. But I think in chemistry, all they care about is a heavy nucleus splitting into two smaller ones. So this one would be correct. And these are obviously any. There's nothing being split over here. So it should just be this one. Okay, and then fusion is the opposite. It's forming one heavy one. Usually it's hydrogen forming helium. Okay, and nuclear fusion, a large nucleus splits. No. Two nuclei come together. Yes. It's exemplified by this. Yes. Hydrogen forming helium. That's what fusion is. It's exemplified by the splitting. No. It's released as energy. Yes. Okay. Mass. Sorry. Anytime mass is released, it's released as energy. Because of E equals mc squared. Okay. In case they ask that. Going back here, the only thing that could possibly work here is if you add something on the left, and you'd have to add a charge of 1 and a mass of 2 on the left. Okay, and the only thing that has this is actually deuterium, hydrogen, 1, 2. Okay, so the name here would be deuterium. Okay, this would work, I guess. Uh, Back here, the mass of a nucleus is determined by adding the mass of the nucleons. Yes. It's determined by adding the mass of the nucleons it contains and the electrons. No. It's determined by subtracting the charge from the mass number. uh no. It's determined by subtracting the atomic number from the mass number. No, we don't really subtract for the mass of the nucleus. Okay, it could be different from the sum of the mass of nucleons. Yes. Okay, it's only these two. It could be different because the electrons, although we don't count them, but they still have a very, very small negligible mass. Okay? And see here the difference. So they did say it. The difference in mass is changed into energy according to E equal mc squared. Okay, in nuclear reactions where mass is lost, the equation needs to be balanced properly. Uh, I don't know. I think yes. Uh, it should be balanced at all costs. Charge is also lost. Charge isn't lost. The mass will be gained by another reaction. No. The mass reappears as other particles because mass can never be lost or destroyed. Well, I don't know, wallah. I actually don't know about D. But I know E is correct, obviously. It changes to energy. Okay. Uh, I actually don't know if any of these are correct. I'm not sure. Okay, but E is correct, 100%. 13. When solid R and S separately react with barium hydroxide, one absorbs and one releases. Design an experiment to determine which process is endo and which process is exo. Okay, we're not going to do any of these. Uh, So actually, no, we'll do this. Okay, in case it comes. You're designing an experiment to determine which process is endo, which process is exo, which process has greater energy change. So we're testing two things. If it's endo or exo. Okay, which process has greater energy change? And they said we have R, we have S, we have a solution of barium hydroxide, and we have common laboratory apparatus. Okay, so we have two R. When R reacts with barium hydroxide, it either absorbs or releases energy, and the same thing goes for S. So we're asked to test two things. You're gonna see these questions a lot in grade 10 and going into grade 11, as well as if you're doing the IGCSE next year and if you're doing AP chemistry. You're gonna see a lot of design and experiment questions, okay? And usually these questions come at 6 marks or 4 marks. They're very heavy in marking, okay? In case they do come, please pay attention. When designing an experiment, you always look at what am I testing. Okay, that's the first thing I ask myself when I'm working with these questions. What am I testing for? So we have two things that we're testing. We're testing whether it's endo or exo. How do we know? You ask yourself, okay, you're testing for endo or exo. So how do I know? How would you test if something's endo or exo? You would check, does it release heat? صح? So if it does release heat, that means it's exothermic. If it doesn't, it absorbs heat, it becomes colder, then it's endothermic. Okay, so how do we test that? How do we test if something releases heat? We're gonna place it a thermometer beside it. صح? So أنا well, obviously not gonna write this, but I'm just trying to like help you think about it. Okay, so endo or exo, how do we test? We place a thermometer beside it, and then you're gonna say if temp increases, then it's exo. And then if temp decreases, then it absorbed energy, then it's endo. So we actually tested the first point. خلاص, we're done. Which process has greater energy change? How do you think you would calculate which one has greater energy change? You would say compare. How do we test? the energy released, we compare the change in temperature. Compare the change in temperature. The one that had a larger change in temperature, you could say the larger delta T, has greater energy change. Greater energy change. So how would you write this? I'm going to open the marking scheme so you guys can see. You're going to say, okay, because when you're working with these questions, you have to be professional. You can't just say stuff like this, okay? You have to be professional. You're going to say something like this. You're going to say measured volume of dilute barium hydroxide. Okay, so basically they're saying you have to say, no, enter you're planning the experiment. You have to say, take, for example, any number, it doesn't matter. Say 10 centimeter cube of barium hydroxide. Take, okay, that's step one. You have to write it as in steps, okay? Then you say step two, place in beaker, okay? This is 1 mark, 1 mark. Step three, measure water at, let's say 10 degrees Celsius, okay? This is your initial temperature, okay? Then we say, we're now testing for R, right? Add 5 grams of R, right? We want to test, we have to do step by step. What happens after we add R? We have to say, measure the change in temperature, right? We want to see the change in temperature. Okay, then, okay, we say repeat for S. And you have to say with same mass. Okay, this is important because we know when using experiments, it has to be for accurate results, we have to use the same mass. Okay, if we use 5 grams of R, then we have to use 5 grams of S. Okay, then what's your conclusion? How do we test? We say the one with positive delta T. So the one that has a positive change in temperature, it increases temperature, is exo. And then you say the opposite is endo. And I'm not going to write it all. And you say larger delta T is larger energy change. If you write all of this, you'd get full. Okay? Some of them aren't required, right? But if you want to get the maximum amount of marks, you have to write this. Okay? Write it as steps. You need to. Okay? You have to be professional, kind of like you're writing an experiment. A student investigates a change in temperature when 3 different solids A, B, and C are dissolved in fixed amount of water. 3 experiments were done. Experiment 1, he measures 50 centimeter cube of distilled water using a measuring cylinder, pours it into a cup, and measures its initial temperature over here. Then he adds 5 grams of solid A and stirs the mixture with a thermometer. Okay, then it was measured after 1 minute. This is the final temperature. He repeats experiment A, but with 5 grams of solid B. This is the final temperature. And then he repeated it with 5 grams of solid C. Use the thermometer diagrams for experiments 1, 2, and 3 to record the initial temperatures and final temperature, and then calculate and record the temperature changes. Okay, you can do this easily, and I'm just going to give you the answer. Okay, you just have to check. They all started at 25, 25, 25, so you put 25, 25, 25. Then the final temperature just recorded. Here it was 20, here it was 19, here it was 31 or 32, 32, and then you calculate the temperature change. Very easy. You just subtract. Final minus initial. Which of these would be an exothermic process? Okay, the exothermic process would be the one where it increases temperature. So it would be experiment 2, because experiment 2 increased its temperature 25 to 32. So you'd say experiment 2 because temperature increased. How would the temperature change? Measured after 1 minute. How, excuse me, how the temperature changes measured after 1 minute differ. If it were repeated with 100 centimeter cube instead of 50 centimeter cube, obviously there would be less temperature change. It would half, okay? Say it would be half. Remember, if if you're increasing the volume, and you're increasing the volume required for it to occupy, okay, then the results will decrease, the rate will decrease, okay? So since we doubled the volume, okay, that means the rate will decrease, so it will half. Okay, it will half. You're doubling, so it will half. They're inversely proportional. These are some of these things might not be asked because we're not required to know this at our level. Experiment 2 is repeated using 10 grams and 15 grams of solid C, and the results of the temperature changes are shown in the table below. Use the data in the table and your answer in part A to determine graphically the temperature change if 15 grams were dissolved in 50 centimeter cube of distilled water. Show clearly on the grid how you reach your answer. So you have to draw a graph and well basically any these are IGCSE questions, yeah. Uh, the, you have to draw and then check from your graph. I'm not gonna go through this because أكيد I'm not gonna say أكيد, maybe they do it. Okay, they're gonna give you this graph, temperature change, mass of C, whatever. You just have to plot the points. Okay, we said the initial temperature, and you have to plot it. The initial temperature, temperature change. Sorry, yeah. We started with 5 grams of solid C, and we said the temperature change here was from the table. You guys should know this. It was minus 5. So at 5 grams, let's look at the graph. At 5 grams, okay, the temperature change was minus 5. So you put a point there. And then now we had, where did they say? They gave us the grid here. Okay, I'll actually use it here. Okay, then they said 10 grams here, right? 10 grams. Okay, so let's plot the points. We said 5 grams over here. It starts at 5 grams. 5 grams, we said the temperature change was minus 5. So you put an X, huh? Please, when graphing, put an X. Please, 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 please. I know some of you might be doing graphs for the first time. Okay, when graphing, always put an X on your point. If you don't, you lose a mark. Okay, and then 10 grams minus 10. So we go to 10 grams. 10 grams, let's just put it over here. And minus 10 over here. If, if you connect the points and draw a straight line, they're basically asking us to estimate yani, from your graph. Okay, at 15 grams. 15 grams would be over here. Okay, so if you take it from the graph, it would be minus 15. So you have to check minus 15. You have to estimate from your graph. In case this comes, any some people might skip this because they think it won't come. And I don't think it will come. Personally, I don't. But know it in case it comes. Another student prepared an identical solution and measured its initial final temperatures. He observed no change in temperature. What did he do wrong? Usually, when this happens, when he observes no change, it's because he waited too long. Yeah, he waited too long, so the heat was absorbed from the surrounding. You have to measure the temperature in the instant of the reaction. If you give it like 5-10 minutes, then خلاص يا أخي, it's gonna all the heat will be absorbed by the surrounding. He probably waited too long. Another student used a glass beaker instead of the styrofoam cups while conducting the experiments. Would his measurements be less or more accurate than the first student? Why? Styrofoam cups are insulators, okay? Insulators. Insulators meaning they don't allow the heat to be absorbed by the surrounding. هلا when he used the glass beaker, glass actually conducts, it's gonna let the heat be absorbed by the surroundings. So would his measurements be less accurate? They would be less accurate because خلاص يعني the temperature is being absorbed by the surrounding. Okay, since glass allows temperature to be absorbed. How can he check the reliability of his results? Always, when you get any question like reliability and accuracy, you always say repeat the experiment more than once. Okay, never ever when doing experiments do we do it once. We always repeat the experiment and find the average. Always find the average. Okay, also that's what they put here. Repeat the experiment, find the average. Okay, خلصنا هون. Yeah, we're done chapter 8. Thank you so much for watching and good luck.